So today I will take you through introduction to data science and machine learning. So I believe you're all excited to learn new skills, and I know that some of you have already been introduced to this technology, but I want to take you further into other areas you haven't explored, and to some I will just sharpen up the skills you already have, and to some you don't even know what machine learning and data science is. Do not worry, this course is made for you, so you won't see it as a strange thing in your life. It's going to be exciting. So let me share my screen. So, introduction to machine learning and data science. And you're with me, Alinafe Mtitimila, the founder of IdealabMw. And I have experience in projects of data science and machine learning. And as a computer engineer, this is also one of our modules. We learn the whole semester about machine learning and artificial intelligence. So this is going to be my expertise area in this training course. So we'll start with what is data science. So data science is the field of study that uses mathematics, programming, and domain knowledge to extract meaningful insights from data. So what it means is that you have criteria, a model that you create in order, when you feed it with the data, it extracts information that you can use for your business or for your company. So in this field of data science, it's not like data analytics. You see the difference as I'll be taking you through what data science is all about. It's a process that you undergo. It's the same as what machine learning is, but in this case, it's data driven. So you'll be getting more data. You'll be putting more data into this model, and it's able to give you insights of what that data is all about. So we'll see examples as we go along, and it applies machine learning algorithms to see insights of numbers. So when you talk about numbers, it may be income statements, balance sheet of your company, text to get what information is in the text, images and videos. So it produces artificial systems that perform tasks that require human intelligence. So instead of you going to find more insight in huge amounts of data, you use these models to figure out what that data is all about. So let us see how the overview of how data science looks like. So as you can see, data science is at the center of other technologies out there. We have mathematics, we have machine learning, computer science, data processing, statistical research, domain expertise. So these areas, they are used in different technologies, but most of these areas, they are data driven. So data science is all about data driven. You get information and you analyze that information to get meaningful data. Most companies right now, for example, I think Facebook, Netflix, they make their decisions according to data, which data they are collecting, so that they can provide good services to their customers. So you can just provide any service to them. You need to get what are their likes, what do they want, whatever is happening in their country, so that you can provide services suited for them. And at the end of the day, you can get more profits. So let us see how a system, the block diagram of a data science system. So the data science system, it starts getting in the raw data. So as you can see on the left side, top left, you get raw data that you have collected. So it doesn't have to be pre-processed, because you are just collecting data. Maybe you are doing data entry. I believe some of you here, you are working in research organizations. You have collected data before. So if your organization use data science, so this is how it's done. So you collect that data, it's raw data. Then you pre-process that data. So you remove all the unwanted sections, maybe they are empty columns. So you remove all those you remove all those anomalies, and you clean the data as the third step. You clean the data and you arrange it. You group it in a way that is presentable. And on step number 4, it says exploratory data analysis. So in this case, that's where data analysis stops. So you actually have insight according to the data you have collected about how many people like this, what people, what should we provide to people in this region. So you have you stop with data analysis in this 4th step on exploratory data analysis. Now then you go to what data science is all about. So data science starts when we go to insights, reports, and visual graphs. So in those, when we say insights, that's when you find meaningful information that you can provide to your bosses or to your clients, what that data is trying to say to them or to their company. And you can also create models and algorithm that that is able to get insights as you go along, because remember, these are data-driven projects. So as the data is coming into your company or in on your organization or in your self-project, you'll be getting that information on the go without even you programming it again. So that is about models and algorithms. They will run in the background for you without providing other programming knowledge. And you can produce data-driven projects. As I already said, that Malawi needs data-driven products, because in Malawi, we use lots of data. We use lots of data and we waste that data. In Malawi, because if I can give an example, maybe today, if you count number of words that you have used when chatting with your friends, with your family, with your partner, there are going to be lots of words. Maybe you have talked about an important issue or important information, but next day, you forget about it. That important information, that idea, you forget about it. What if we collect that data and extract useful information that we can provide products for Malawians? I believe everyone here has ever think of a good idea that can increase our economic growth. But telling you, maybe 10 of the ideas, maybe 6 of them, you have already forgotten about them. But data science is able to remind you and is able to give you insight what that information is all about. So let us take a look about the life cycle of a data science project. So a data science project starts with business understanding. So in this case, you define the problem statement. What do you want to achieve? Where there's what problem is there you want to solve? So let's say in agriculture, you want to maximize maize produce, because in Malawi, maize is becoming more expensive every day. So you get that information. You get that information when you doing project business understanding. Then you go into data collection. Remember, these systems are data driven. They will require data for you to generate the required or the desired results. So you collect data about why men's yields are expensive, why lanes, or every data that is relevant, that you think is relevant. Then you prepare that data, because not every information is useful information. So you prepare that data, you extract unwanted data in your systems. Then you do data analysis. You express your data in data visualization tools like graphs, so that you should see the trend in a presentable way. Then you create a model that will be used to tell you more, or the insights of the data you have collected. Why? This step asks you why, gives you answers of why that problem is happening. Then you evaluate your model to see the score, how your model is working in the real world. Then you can deploy into production. So that's how life cycle of data science project looks like. Let us take a look about examples of data science projects that are there in the world. We have climate change impacts on the global food supply. So this is into agriculture. It's the same example that I've given you. We have fake news detection. This is also one of the problems we have in Malawi. If you go on Facebook, most of the stuff you see there, they are fake news. So this can disrupt the political stability of a nation. But with data science, we're able to detect that this news is fake. We have human action recognition. This also is used in FBI, I think in America, whereby they will detect if you are lying or not. We have forest fire prediction, to predict if the time of the year when fires will erupt in the forest. Road lane line detection. So this is in cars, these cool fancy Tesla cars. Recognition of speech emotion. I remember, I think in UK, last year they have implemented a speech recognition, I think in Parliament, to see if they are inserting another member of Parliament. So you don't need to hear what they're talking about, you just need to detect their lips. So which is a good project. So it's data driven. If you can see all these projects, they require data before you model them into production. So that is all about data science. Now let us go into machine learning. If you have any questions, you have time to answer in the last section. So what is machine learning? So it's a subfield of artificial intelligence, which is broadly defined as the capability of a machine to imitate intelligent human behavior. So basically, it's your computer to do the works of a human being, what you can do and do it even better. So it's essentially a set of rules defined by a human. So you define what the machine is going to do, and it's going to do that perfectly, and it will never get tired of doing it. So that's the good thing about machine learning. So let us take a look at types of machine learning. We have supervised learning, we have unsupervised learning, we have reinforcement learning. So there's a fourth one, which is trending nowadays, called semi-supervised learning. So one example of semi-supervised learning, we are not going to talk about it in this section, but one example of semi-supervised learning, it's language translation. So language translation, you can see that if you go on Facebook, light in Chichewa, it will tell you can translate that into English, and you're going to see the performance is somehow poor, but it still translates. It means it has good data of translation, but it's not that perfect. So you can use those already modeled, already machine learning models to apply supervised learning to them, because that is what we call transfer learning, if you have ever heard about transfer learning before. So you don't need to have lots of data to train them. You can actually use already trained models and retrain them with your data. I believe Inc., which was Skybound, is using the same thing to detect thieves in different companies when they store their cameras. So supervised learning is the type of machine learning in which machines are trained using well-labeled training data, and on the basis of that data, machines predict the output. So what it's trying to say here, you tell your system which data to search, which data to focus on. So you can give your machine, you can train your machine to say, if you see this, this is a cat. If you see this, this is a dog. If you see this, this is a car. If you see this, this is a motorcycle. So next time when your machine has learned enough, it's going to detect that without your intervention, because you have already trained that machine to detect those objects. So the training data provided to the machines work as the supervisor that teaches the machine to predict the output collected. So it's like you are supervising it. This is what you should do. It's the same as in class. If your teacher says 1 + 1 = 2 and you put 3 there, you're going to fail because that is not the correct output. But I believe that you are all geniuses here. If they say 1 + 1, the answer is 2, and you are going to put 2 in your exams. So types of supervised machine learning, we have classification and regression. So when you go to classification, it predicts discrete class labels. So it predicts discrete class objects, or it can be anything, but it has to be discrete. Example, we have machine learning model being asked the question, will it be cold or hot tomorrow? So a classification model will actually answer you hot or cold. It will not give you a range of values. So it will only answer with the discrete values. This classification model, you can use it in image detection to detect if that is a car or a dog or something. So that is all about classification. But speaking of giving you the actual value, we have got regression. This is the type of supervised learning whereby it predicts continuous quantity. So as the question says, what is the temperature going to be tomorrow? It's 84 degrees. So it gives you the continuous value, the exact value that you are looking for. So this regression is mostly used in hospitals to detect diseases. So a disease cannot be discrete, but you can actually see the symptoms that are residing into that disease that you are facing. So let us go to another type of machine learning, which is unsupervised learning. It's a type of machine learning in which models are trained using unlabeled data set and allowed to act on that data without any supervision. So you just feed the machine without labeling the data. There is no pre-processing in this case. So you just feed it. So the machine is going to do it. It's going to act upon it and give you the insight. So the goal of this supervised learning is to find underlying structure of dataset, group that data according to similarities, and represent that dataset in a compiled format. So let us take a look how machine learning is typed, because in this case, I will explain more how it's done. So we have two types of unsupervised learning: clustering and association. So clustering, what it does is grouping the data points. So you feed it with data and you give it a rule. So in that rule set, you say, can you group adults and children depending on weight and height? So it's going to do that for you. So most of the times, unsupervised learning, it's done in order to mine data that is found in huge data sets. So if you have ever heard about big data, this is where unsupervised learning shines on. So they try to extract lots of data using unsupervised learning by clustering and association. So in a clustering, it's just grouping. It's a cluster. So you want to group depending on a certain feature that you have put in your model. So we also have association. So association is finding relationship between attributes of those data points. So this is done in forensics accounting or forensics auditing. So to find patterns of why this happens. So how is this related to this? How is this related to this? So this is very important in finding patterns of why something is happening, or the occurrence of something in your area. You can find patterns of why maybe education system is going low in Malawi, it's not going to be a single factor. There are lots of factors in this case. So you use association, which is a branch of unsupervised learning. So let us go into reinforcement learning. So it's a type of machine learning technique that enables an agent to learn in an interactive environment by trial and error, using feedback from its own actions and experience. Uses rewards and punishment as signals of positive and negative behavior. So reinforcement learning is mostly used in robotics. And mostly used in robotics, because you want to train that robot on how to walk, how to behave in a certain way. But it's a robot. You can't feed it more data. You can't feed it data, but you can teach it. It's the same as how our parents have raised us. If we do something right, they will reward us. If we do something wrong, they are going to slap us. So if they slap us, next time we are not going to do that again. We'll refrain from doing that again. If they reward us, next time we're going to do the very same thing, so that we should increase the reward that we already have. So that's how reinforcement learning works. So you can use this in robotics. I believe if we have a paramedical engineer in our midst, I believe you do prosthetics. So this is how prosthetics are done. You want to grab something. If it doesn't grab it, you're going to punish it. You're going to give negative reward. And next time it's not going to do the same thing. If it does that, you're going to reward it. So that's how prosthetics works. So it's no magic, it's just machine learning. So we have two types of reinforcement learning. We have positive reinforcement and negative reinforcement. So positive reinforcement means adding something to increase the tendency that expected behavior would occur again. So in this case, you are rewarding, you are giving a positive reward to the machine. So in this case, there's a diagram showing a child making the bed. You are rewarding it, and you are next time she's going to do the very same thing, so that it should get it excites her. That's why she's doing it again, to get more reward. So increase the more desired behavior of your system. So it's going to train in that way. And we also have negative reinforcement. So negative reinforcement, this case, it's in negative reinforcement, it increases the tendency that the specific behavior will occur again by avoiding the negative condition. So in this case, you are giving a negative reward to your system so that it will never do that again. In this picture, we are seeing a robot that is used to walk in a certain direction. So if it goes in the wrong direction, you're going to give it negative reward. And thereby, at the end of the day, it will do the same thing. It will do what it's intended to do, but it will avoid areas where you give it negative reward. So this is about the introduction to machine learning and data science. I don't know if you have any questions on the details and the presentation that I had for you this morning. If you have any questions, you can also use the message chat to ask questions, or if you need more clarity in a certain sector. But this is the simplest introduction that I wanted to provide to you in this course. Any questions? We are seeing from Frank saying none from me. That's excellent. Okay, Virus is saying help with a little bit of summary. Just join, just so I can get an overview. So we are talking about data science and machine learning. So data science is all about data-driven projects, data-driven systems, whereby you get more insight with the data and you give it a model, an algorithm that will be able to give more insights as data is coming into your system or to your project. So that is all about data science. And machine learning, it's about a technique that you train your machines to act with human intelligence. So in this case, your machine is able to predict values, is able to classify objects, is able to cluster or group much information in the system, and you can also reinforce your machine to act in a certain way you want, same as robotics, how they can work, or even drones, how they detect an object and fly in a certain way. So those areas, they use machine learning. So that is a simple summary that I can give you about the session we had this morning. So you're welcome, Virus. Any questions? Is this course more concerned about programming? All right. This course, it's about programming, but it's not that heavy programming that you know about creating other systems. We are going to use Python in this course. So Python is a higher level language, meaning to say it mimics human language. So I will take you through the process of how you can get going with Python. It's a very simple programming language, so you can get more insight. And with a little bit of programming, maybe 2 sentences, you're able to get predictions of what that data is talking about. So don't worry about programming or what. I will take you through this process. It's a very simple process. If you have this, if you know a little bit of Python and apply it in your field, yeah, you can get more data. And data science and machine learning, this is a vast field. You apply machine learning in civil engineering. I remember a certain guy approached me about a project of detecting strength of materials. So you can apply in every field, even in churches, you can apply machine learning. So don't worry, I will take you through this process in a very simpler way that you can understand. Yeah, so I don't know if that answers your question, Telisa, but thanks for the amazing question. Any questions so far? The more you ask questions, the more insight you are going to get from what we have discussed. All right, from Frank, you're saying maybe you should give us the what should we expect after attending this course. So as I said in the beginning, these entry courses are here to introduce you to the technologies that are out there. So I wouldn't say that after this course, you are going to be the major in data science or machine learning. Then I'll be lying to you. But after this course, I'm going to show you what you can be capable of if you use these technologies, because you get more, you get introductory insight. I already said that if you do binge watching on YouTube to learn this type of technologies, you are going to have some hassles. It's going to overwhelm you where to start. So I believe most of everyone here is curious of to know what machine learning is all about. So, but where to start? You can have all the resources, but where to start? It's the question that most of us, we ask ourselves every day. So this entry course is going to open your eyes on the possibility that you can do with these technologies and where to start from this technology. So in the professional course of this course, professional side of this course, that's when we will be building together enterprise system. So in the enterprise system, we'll start from research, how we can get data, how we can pre-process data in a very professional way that is used out there. So that's what we're going to do in the professional course. We'll build those systems that you can put in your CV, let's say. But in this course, it's going to help you to get started, as it's the purpose I already said in the beginning of this training program. All right, I think this is the last question, which is exciting from Togo. All right, we'll take us to another one. Please give a simpler example of application of machine learning that we interact with in our daily lives. And is this technology new? It has been, or it has been there back in the ages. So yes, you do use machine learning applications every day. You use them every day. For example, on your keyboard, on your cell phone keyboard, it predicts which text that you should write, or if you have misspelled a text, it predicts that you should put this text. You use that. If you use Facebook, it gives you information that you want. Or for example, I can give you a trick. You can put your phone on data, then speak about cars and go on YouTube. You find that they are suggesting that you should see they are suggesting videos of cars. And the cool one, you can use Google Assistant. You just say, hey, Google, your phone is going to be detecting and when I said like that, my phone is able to is preparing itself for Google Assistant. So you use that every day. And also this technology is not new. It has been there in the 90s. So it has been there. People have used it, this one, specifically in data science. So most people, the gurus of statistics, they have used this one because behind machine learning, there is statistics. So it has been there and they use it every day. So thanks, Togo. We have the last question from Trace4. Does this course explain more similar as to robotics? Yes, definitely. But we are not going to do reinforcement learning much. But the same criteria that I will teach you here, you can apply it in robotics. So those areas are going to be done in the professional course, because we will need equipment for robotics and to train them. But we will do that in the professional course. But the very same criteria you can apply in robotics. So that's what we'll do in the professional course. And this course is also going to run for 2 months. So yeah, within these 2 months, we are going to learn a lot on machine learning. So far, this is where we stop. If you have any questions, you meet me, you ask me in the Discord channel, in the machine learning and data science community. So thank you very much. You have been a wonderful audience. See you next week on Wednesday this time around. So thank you.
Thank you.